So welcome to the P4 Developers Day. I'm Nick McKeown. I teach here at Stanford in computer science, electrical engineering, and Jen Rexford and I are the official board members of P4.org. Our job is to try and keep it going, flourishing, and independent. And Jen unfortunately has the last throes of the Princeton term today, so she's not able to be here. So I'm here to represent both of us. So welcome here to Stanford. If you haven't been here before, it's a beautiful day. I'm not going to use any slides because you're going to see so many slides today. I thought the last thing you needed was some extra ones in the morning. And I'd like to keep this informal in the spirit of what this day is all about. But before we get going, I just wanted to call out and thank a few people who have helped bring the day together. There's a huge amount of work that goes into the material, the tutorial and the learning material that you're going to be covering today. So there's been quite a few people from Metronome and from Barefoot and from others who have been working hard to get all of that material together today. So you'll see that as the day goes on. I wanted to particularly thank AT&T, Metronome, and Barefoot for helping sponsor the day. The way the sponsorship works is we go plea with everybody to help defray costs so you pay less for registration. P4 is a non-profit organization, and so we use all of the money that we get for the sponsorship to try and reduce the cost for the day, pay for this room, pay for the videographers, things like that at the back. Clearly what this is all about, what P4 is all about, is part of this bigger trend of hardware in the infrastructure moving to software. Right? We all see that trend, we all hear about it, we hear these phrases like, software is eating the world. And this is a part of that bigger trend. We're all familiar with the iPhone App Store, the movement of things that we used to think of as dedicated devices, GPSs, things like this, compasses, that suddenly just become apps on our phone. While I don't want to trivialize this change that's happening in networking and say it's just like an app store, clearly it's more than that, it's different from that. But the same trends are underlying it. This movement towards software, because it gives you more agility, gives the ability for people to share code, and it empowers many thousands, many tens of thousands of developers. So this trend is, in networking, I heard it described last week as taking protocols and moving them off chips into software. And I think it's a nice way of characterizing what's going on. So those protocols and features that we tend to think of as hard baked in are being lifted up, the protocols themselves, lifted off chips into software. And, as part of this, developers like yourselves are going to assemble forwarding planes from heavily QA'd software that you have produced, others have produced, the open source community has produced, libraries to which you then add your own secret source. That's how all software gets written. And just imagine if someone had said to you 10 years ago that that's how networks were going to be built, it would have seemed fanciful, right? But already the fact that you're sitting here and the fact that so many of us are devoting our time to it means that we're beginning to assume that that's how it's going to go. So assembling forwarding planes and forwarding plane behavior from heavily QA'd software, libraries to which we add our own secret source. So when you're looking for places to start and examples to start from, I'd encourage you to look at the GitHub repository that's on p4.org. Many of you will have looked at it already. And in there you will find the switch.p4. And switch.p4 is a great place to start. It's been put together by a team of people that who used to build forwarding planes for big networking companies. And so they know what the data center forwarding plane looks like. And it's created as an open source description of a typical top-of-rack switch. So it's not a toy. It's something that you could compile turn into a chip, an ASIC, or a programmed device, and it would function as a top-of-rack switch in a typical data center today. So if you start from that and enhance it with your own secret sauce, you're starting with something real. Of course, I would encourage you to contribute those back, but it's all Apache license. You don't have to. You can take it, add it, keep it for yourself. You can contribute and then allow that whole corpus of code and expertise to grow. I think that DevOps teams, of which there are now many in networking, will use this approach not only to enhance their network, they'll use it to simplify and streamline their network. This is another big use of programmability. Throw out all the crap you don't need. Start with switch.p4, identify the things that you don't need in your environment, throw them out. Because by simplifying and streamlining and throwing out protocols you don't need, you're going to devote the resources that you need, the focus, the attention, the smarts, to those things that you do need. Many, many outages in big public clouds have been attributed to protocols that were running in systems that the operator didn't even use, because it came to haunt them because it was sitting there like a time bomb waiting to go wrong, and then they didn't have any expertise available in order to be able to debug it. So throw that stuff out, and once it's programmable, then it allows you to remove, to simplify and streamline down to boil it down to only those things that you need. And I think that DevOps teams will also use P4 to quickly debug and troubleshoot networks. I love the story that one big public cloud provider told me, and that was the situation when something goes wrong in a big public cloud. Massive teams are brought together as quickly as possible. Folks from compute, folks from storage, folks from networking, and they're all put in a room together in order to try and fix it, a war room to try and fix the problem. The compute people come with huge streams of logs, they've got experiments, they've got code, they've been repeating the problem, they've been able to reproduce it. The storage people can do something along the same lines. And the networking people, they have ping and traceroute. What we know is you can't run experiments in a network, and everybody will tell you, because it's carrying live traffic. Why is it that I can run experiments on my server that's running what live workload? It's much more complicated, much more likely to go wrong. It's because I trust my ability through the tools that I've created and that others have created in order to be able to run isolated experiments. And I understand the value of being able to reproduce the error and see the logs that they produce. So we need to move to making that commonplace in networking. And if you can modify the behavior of the forwarding plane, whether it's through configuration software or actually a P4 program running on it, on the fly, in order to be able to change its behavior and see what happens, then of course you can troubleshoot and debug a network that much faster. So I think that many of us already know and believe that this is going to be, in a sense, the killer app of being able to change the forwarding plane behavior, giving the agility to do debugging much faster. But I also think that P4 will be used by organizations like the IETF and other standards bodies as a way to unambiguously specify forwarding behavior. We all saw in the last workshop, or many of you will have seen in the last workshop, an example by AT&T using P4 as a way to specify forwarding behavior that they handed to a vendor and said, that's the behavior I want in my box. And that changes the dynamic to those who own and operate networks to be able to specify a behavior and say, I want that standardized so that many people can provide it to me, or I want this in all of the boxes that I build. So I think that use of a unambiguous language to formally describe in a way that you can test, prove, verify that forwarding behavior is correct will take us away from this sort of funny chaos we have today of thousands of standards written in ambiguous English for which each piece of equipment has to be painstakingly tested against all of the others to find out whether they interpreted the same English the same way. As soon as you have a unambiguous and formal specification in a language like P4, then you get a much quicker process of testing for interoperability and finding out whose box is really compliant with the standard. And finally, I think that big network owners, those who devote huge resources today to middle boxes, whether they're load balancers, or huge numbers of servers being used for load balancing, for various types of gateway, I think those will be folded into the plumbing. Because as soon as you can enhance the plumbing in order to include features that you have in your large network, then you will. And you will eliminate all of those expensive middle boxes in the process, or extra monitoring networks, things like this. And at the end of the day, the reason for doing this is not only to improve the quality of the network, but because you own the ideas yourself. If I add an idea to my network, I can choose to share it, or I can choose to use it as differentiating feature to beat my competitor. And people will do that too. So if I'm Amazon and against Google, or if I'm one big provider competing with another, if I can add features into my network, the network is my business, then I can improve that network, differentiate, and have a better network than my competitor, perhaps one that isolates traffic better, one that I can prove that one tenant can't communicate to another. As soon as I can do things like that, then I will, and I'll keep it for myself. So we'll see some of that behavior as well. So today, if you're new to P4, I encourage you to learn about what P4 is. But in addition to that, give some thought to how you can be part of this growing community. Because these communities, they grow out of individuals who spend and devote their time, like I am, like many of you already are. All open source communities work this way. There is no one who has a full-time paid job to be here working on P4 as part of a workshop like this. There are people whose jobs are now increasingly including this as part of what they do. But this community gets created by you, by us, by everybody working together. So yes, look for things that you can take, look for things that you can put back, look for things you can contribute, look for other people that work in other companies that may or may not be compatible or complementary with your company. Just look for ways to help us build this community together. So use the tools, contribute tools, think about tools that need to get built. Whether you're a developer, an operator, a researcher, and people who get involved when the community is small like this really actually are very influential. If you look at OpenStack, those people who were involved in OpenStack when it was about this size have been super influential, and their influence has continued in terms of the code that has been produced and the architecture of the OpenStack software. So it's a great time to be involved. If your calendar allows, if your time allows, come tomorrow for the rest of the workshop, where you'll see lots of demos and some talks by other people who are using P4 in their network. So I encourage you to come along tomorrow. If you have not registered for tomorrow and you still need to, the folks who are at the reception outside, at the registration desk outside, can help you register for tomorrow. I think there's a discount rate for everybody that's attending today. So finally, I'd like to thank again the people who have been arranging today, whether they were the sponsors or people who have been putting a lot of effort in: Intel, VMware, Xilinx, Netronome, Barefoot, and of course the sponsors. A last word about the video. You can see there's a video camera running at the back. The goal is for all of today to be recorded and available online afterwards for you as the attendees to share with others. We are going to be asking the speakers to sign release forms, so it will be dependent on the individual speakers, but this should be available afterwards. So, thank you for being part of this community. Look forward to continuing to work with you for many years to come as this grows and expands into the whole of networking. Before I hand off to the next speaker, does anybody have any questions or comments before we get stuck into the day? Tom.
Why just forwarding plan? Why not apply P4 to other layers?
So the question was why P4 is focused on the forwarding plane. So, over the last 10 years or so, as we've seen more of the networking infrastructure be sort of redefined in software, more than just this term software-defined networking, but in general, much more of it being in software that's open. It's now possible for big network operators like AT&T to commission software to be written for others to control the network, to write your own, to download open source and modify it. In a sense that has a momentum which is already going, right? That momentum it's unstoppable. I don't know what it's going to look like in 10 years. That's the nature of software, but that's already going. The forwarding plane has been off limits. And we can't use the same software tools, the same software environment, because the forwarding plane has specific characteristics. It's a different domain. We need domain-specific processes. We need a domain-specific language like P4 that you can compile to efficient, fast code. So it's a slightly different beast. Now, what I think your question is very important is that it leads to the necessity of how that control plane software will integrate and work well with that P4 description of the forwarding plane. And that I think we're experimenting with right now. Right? Today people are writing P4 code, P4 programs that get compiled and generate the API to communicate with the control plane. How will all that be exposed up to the eventual user, owner, and operator of the network? That's not entirely clear right now. Right? So these do need to work in concert, but I think they're slightly different beasts. Okay, I'm going to hand over the floor to Patrick O'Sullivan from Goldman Sachs. Patrick has been thinking a lot about how P4 can be used in a big enterprise environment like Goldman's networks, and he's going to tell us about that right now. Thank you. Thank you, Patrick.
Thank you, Nick, and everyone, all the sponsors and organizers. A lot of hard work going into this today. First of all, why am I here? And the reason I'm going to address this first is because I was at, for instance, OCP Summit a month and a half ago, 2 months ago, and everyone who came up to our booth asked, why is a Goldman Sachs at Open Compute Project? So we think a lot about technology. Technology is the largest division in our company. We have thousands of application developers. We have many different businesses, investment banking, trading, consumer finance, we're getting more into now, and really applications power it all, and the network sits at the heart of a lot of it. In terms of open networking and other open source movements, we're on the board of Open Networking Foundation, Open Compute. So these things we find really do have opportunity to change how we operate our technology, but then our business also. It's a very commercial thing. But what about P4? They asked me to talk about what excites me, what excites Goldman Sachs about P4 specifically as a technology. First and foremost, we appreciate very much the so far broad adoption and interest in P4 as a technology across academia, hardware vendors, and software vendors. One thing I've noticed is there seems to be a little less fear, uncertainty, and doubt about P4 right now than there was about OpenFlow, for instance, in the early days. And several years ago, when we'd go to talk to an incumbent network vendor about OpenFlow, it was a very defensive conversation. They thought that somehow that was going to take money away from them. Now, we have conversations with the same incumbent vendors, and they're excited about P4. That's interesting. Much different story. And touching on something that Nick highlighted on, recently I was in a meeting with such a vendor, and we were talking about doing something a bit custom. And after about 25 minutes of trying to verbally describe the problem and a proposed solution to it, someone from the vendor said, "Would you be able to write that as a P4 program?" Just to express, as Nick was talking about, unambiguously something that we'd be interested in the network being able to do. We're also interested in it because we feel that it's come along as an abstraction at the right level. And that kind of works both organizationally and technically for us. So for instance, we have a pretty large development team inside our network engineering organization. I project that over the next few years, it'll be the majority of our network engineering organization. But we have to pick and choose where we invest our developer resources. So for example, we've put a lot of work into inventory, into automation, specifically with our environments that require some tighter security than is customary in kind of most networks. But we've said no to doing things like developing custom network operating systems or perhaps programming existing ASIC SDKs or APIs directly. We haven't found the right set of value there to trade off with the complexity and the resources of doing that. But in contrast, we do see ourselves using P4 as something to program our network and make it operate better for what we want it to do. A slight example about this is that we did some early experiments with OpenFlow, and it was useful for certain problems. And what was frustrating at the time was that there were things that we were able to express and we knew we could solve via OpenFlow. But the layer of abstraction that OpenFlow sat at meant that even though we could define that, we could do it, and perhaps even implement it in software, there was a disconnect between OpenFlow and how it would end up getting programmed in the hardware. So in other words, intelligently translating what our intent was to actually what was going to happen in the ASIC, it wasn't possible. And anytime that we approach this problem with either an ASIC vendor or an OEM, someone writing network software, we would get differing answers as to whether or not the pipeline could even do what we wanted to do. And once we figured out, yes, it can, every solution we got was, can we write an extension to OpenFlow? It wasn't going to be anything standard anymore. So in contrast, P4, we can say exactly, declaratively, what we want to be able to do. And if it fits in hardware, great. We can go ahead and do it. And if you haven't seen it yet, there's a great post by Nick and Jen on the P4 blog recently that compares and contrasts OpenFlow and P4 and why it's a solution to, P4 is a solution to a different problem and why there's a lot of value in it. Another reason why P4 interests us is because we don't always want the out-of-the-box solution from a vendor. We sit in this funny place where our infrastructure is not web scale, it's not Amazon or Google or Facebook size, but the problems that we try to solve on the network aren't always the same as our peers or other companies of our same size. So we look at what we can purchase from a vendor, doesn't necessarily fit in what we want to do, and that kind of leaves us in a funny position where if we end up getting a vendor to work on something for us, we become literally I've had a vendor tell me this, the 1 out of 200 of their customers wanting this thing. And we don't want to be a snowflake in that regard because it just creates differing interests between you and a vendor. We often see the same thing with protocol standards. And perhaps if you look at a spec sheet for an ASIC, and it says it supports RFC this, IETF this, that, and the other thing, and it's like, well, all those things mean that the hardware is capable of doing things we're interested in under the covers, but we're perhaps not interested in all the things about that protocol. And so how do we separate those two things and get the functionality that's in the hardware that can help us without having to perhaps go through the heavy lifting of implementing a protocol that does more than we need to do or really isn't made for the problem that we're trying to solve. And lastly, we don't want to wait on others if we don't have to. So if there's a problem that has commercial opportunity for us and we see ourselves being able to develop some code that can solve that problem, great. We'd love to be able to implement that sooner rather than later because even though the vendors can be pretty good at turning around features, sometimes it's just not as quick as you'd hope it to be. Another thing that we see in financial services is a lot of custom protocols. So whether it's for market data coming in from some sort of exchange or an internal application protocol, There's a lot that goes on there that perhaps is not familiar to a lot of folks outside the realm of financial services. And the idea of being able to, quote unquote, see these protocols in hardware is immensely powerful because it means that we can embed some of the functionality that Nick was talking about before that otherwise is handled in middle boxes, whether they're network middle boxes or whether they're custom applications just running on a server to do some effectively network-oriented task. Being able to drop those down into hardware could perhaps accelerate things, deliver things at a lower price point because they can be done more efficiently in hardware. And we see that as hugely advantageous. To date, anything to do with this sort of this idea has been FPGA driven, and while many folks perhaps have Verilog or VHDL developers on staff, we don't, and I see some gentlemen over here smiling. We don't, and it's another area where we haven't chosen to invest. So again, we see P4 as and chips that are capable of using it as very interesting. We've gotten pretty good in our networking software development in doing testing, whether it's just particular testing on our code or in some of our environments where we have end-to-end orchestration, automation, security policies, really testing the whole stack. And we're quite happy with how we've done in that regard. But every time we decide that we need this testing environment, we need a UAT, we need a QA, we end up buying literally racks of hardware. And so we can automate our code really well. It's running on servers, and we can even automate all this hardware to do the testing that we want to do. It's kind of a waste to throw all this hardware into a rack just to do a little bit of testing, or perhaps every time we kick off a build, make sure the thing is still working. So the weak link in that regard is really the hardware, and being able to test in software. And again, another theme of what Nick mentioned is hugely powerful. And the idea of correctness, provably, to our information security folks, don't tell them I mentioned it, because they'll be very excited by the fact that we can have provable security in some of our environments. And we actually do want to get closer to doing that for where we have real security concerns. As far as monitoring and telemetry goes, that's an area where, again, Nick mentioned this, and I literally have some emails sitting in my inbox that outline the exact scenario that Nick talked about, where there's some reproducible tests of the network not operating appropriately, and all we know is, well, it's green, looks good. Now we have to open a ticket with a vendor to understand why something from one test to another is behaving differently on what is effectively a black box to us. Wouldn't it be nice if we could say that on that black box, we're going to open it up, we're going to, whether from the start or from now that we have a problem, add some telemetry in there to figure out what's going on. And the other thing is that right now when a box ships or an ASIC ships, its ability to do any sort of telemetry or monitoring is fixed pretty much from that day forward. Maybe there's some changes to software that are implemented that give you some more functionality, but fundamentally the chip does what the chip does. And the monitoring tools that are in boxes are blunt. They're meant to send a packet capture somewhere or generate some logs on something. The ability to program monitoring into the data plane, into the network fabric, that's specifically useful to the application that's having a problem is, again, an extremely powerful tool. And we think ultimately that will lead to more stable networks with less downtime. And this one I think is interesting and continue to evolve over the next few years. The idea of one data plane to rule them all. What do I mean by that? Let's say, like AT&T making an ATT.P4, we make a GS.P4, and it describes our data center forwarding semantics, how we want all our security to be implemented, what tables we need to be able to use, and how we're programming the network. And we do all this great stuff. The idea of being able to take that and put it into programmable hardware is awesome, but it's really cool that we could take that same program and then through something like eBPF in the Linux kernel, compile that into every machine that we have that's running Linux and do the same exact thing both in software or in hardware and pick and choose which one we want to use for a given problem. So to summarize things, I think the last few years of networking have been really fun with open networking in general, even though software defined this and that, kind of the media took that and ran with it. It's really made networking exciting again, and I think it's only going to get better with technologies like P4. So I'm excited to be here. I'm excited to learn more about P4. If anyone wants to have a chat about anything, please feel free to find me over the next 2 days. And shameless plug, if anyone's interested in working with problems that a financial services institution might have, and you like the New York area, also come see me. Thank you.